For this Vodcast, please have note page number 22 in front of you. This is our last topic of Unit 11 in dealing with organic compounds. And what we're going to focus on is organic reactions. Now, with organic reactions, we're going to see that there are 7 different types of these organic reactions. For this Vodcast, we're going to focus on the first 3. All right? We're going to talk about combustion, substitution, and finally addition. And then in the next Vodcast, we'll focus on the last 4. So, combustion in dealing with organic reactions. It's also known as oxidation. It's when a hydrocarbon, right, the hydrocarbon can be an alkane, an alkene, or an alkyne, is burned in the presence of oxygen. And so the O2 is going to be one of the reactants along with the alkane or the alkene or the alkyne. What's going to be produced is water and carbon dioxide. Right? It is highly suggested that you get to know this chemical reaction for combustion, right? Because it is quite often seen on the Regents exam in June. All right, now let's take a look here. So what you're always going to have produced is the water and the carbon dioxide. That's always going to be produced within this combustion or oxidation chemical reaction. So an example would be, let's see, if we go with C3H8, right, this is propane. Right, this is our hydrocarbon, alkane in this case, is going to react with oxygen, O2, oxygen gas. What's going to happen is the process of combustion. And what you're going to have produced is going to be CO2, that's our carbon dioxide, and then naturally H2O, which is going to be our water. This is a reaction that is always going to produce these 2 things. The carbon dioxide and the water will always be produced. All right, another example, or it's generic example. If you were given an alkane or just a hydrocarbon, all right, here's your generic formula, and oxygen gas, what's produced, like we said, is going to be the CO2 and the water. All right, that's pretty straightforward, pretty simple as far as organic reactions go, right, dealing with a combustion reaction. Now, the second type of reaction, this is called the substitution. With the substitution, you're going to have 1 or more hydrogen atoms within a saturated alkane hydrocarbon is going to be replaced or substituted by another atom or group. All right, so let's take a look and see what we have here. So we're dealing with, let's go to the basic generic formula first. You have some sort of alkane that's reacting with a halogen, group 17 elements. And what's going to be produced is what's called a halocarbon, which I'll show you with a couple examples here, and some sort of acid. All right, so if we stick with the same alkane that we used in the previous problem, let's go C3H8. And once again, this is propane. And that's our alkane. That chemically reacts with a halogen, and we can use, let's go Cl2 here. What's going to happen is the halogen, one of the halogens is going to replace one of the hydrogens that's found within the alkane to produce C3H7. One of them's replaced, and a Cl is now going to be attached. One of the halogens is going to be attached to the alkane, and what's also going to be produced is HCl, hydrochloric acid. Let me draw this out for you. All right, so if we start with our propane, C, C, C. And here's all of our hydrogens that would be present in this propane organic compound. That's going to be reacting with a halogen. In this case, it's going to be the chlorine, bonded like that. And what's going to be produced is this. Well, what's going to happen is this hydrogen, choose this hydrogen here, is going to be replaced. All right, watch how this plays out. And let's draw the base of our propane molecule. It'll look like this. And what's happening now is that at this location right here, the hydrogen is being replaced by the chlorine. And then what else happens, what else is going to happen here is that since we had two of the hydrogens replaced, we're also going to have another product. It's going to be hydrogen. That's where this H comes from, is now here on its own. So we can somewhat extend this. There's the hydrogen there. And the second chlorine is going to be attached here as well. So you have HCl. So just to kind of repeat this, here's your first hydrogen being replaced by the chlorine. So this hydrogen is going to be kicked out because the chlorine is replacing it. And the second chlorine is now going to be attached to the hydrogen that was kicked out to give you your acid portion. So here's your halocarbon, which is basically a hydrocarbon, where the halo is replacing, the halogen is replacing one of the hydrogens with a chlorine. All right? And the third type of organic reaction is called addition. This is where atoms, groups, are added at the multiple bond. Right? The multiple bond obviously being a double or a triple of a unsaturated, right, double or triple bonded hydrocarbon to become a saturated halocarbon. All right, so now we're dealing with the halides again. Two reactants turn into one larger product. All right, so basically what we're doing with this whole addition chemical reaction is that we are replacing a multiple bond that's being converted into a saturated halocarbon, which is going to be singular bonds. All right, so example, here we go. Let's say we have C2H4, right, ethene, right, and that's going to be combined with a halogen, which is going to be chlorine, again in this case. What's going to be produced? Well, we got two smaller reactants. We're going to produce one larger product. We're going to have C2H4Cl2. This looks very similar to a synthesis reaction that we talked about earlier this year. So in essence, just to write this out in terms, what you're going to start with is going to be an alkene or an alkyne. You got a halogen involved. And what's going to be produced is what's called, once again, a halocarbon. All right, here we go. Let's draw it out. All right, here's our double bond of carbon. Hydrogens branched off of each of the carbon, two of them. That's going to be chemically combined with a diatomic halogen. In this case, we're using the chlorine again. And what's going to be produced is the breaking of that double bond, first and foremost. We don't add any carbon to this. We still have the same number of carbon, but we're going to have a different amount of hydrogens. Right? There's 4 hydrogens. And what happens is through the whole process of synthesis, these two chlorines are going to kick out the hydrogens that were there and complete our single bond of our hydrocarbon. So we've gone from a double bond broken up into single bonds. Okay, so take a look at these three different types of organic reactions. And of course, if you have any questions, bring them to class the next time we get together.